Hey, I'm Kurt, and I work for Uber on the mobile platform team. And part of our job is making mobile developers' jobs easier and also at the same time trying to improve the quality of our apps. And we've noticed that there's a common set of things that maybe we can help out and make better by creating libraries. And in fact, I used to do the same, very similar job back at Google, and we had the same set of problems, unsurprisingly. And so here I'm to talk to you about a new library that helps solve a problem that I think everybody has, but they don't necessarily realize they have. So I'm storing app data reliably and performantly is something that hopefully everybody wants to do if you're not already doing. I know we're in New York and you're used to the subway, which is not reliable or performant at all. And that's no fun. It's bad when things don't behave how you expect them to. And so last time at droidCon San Francisco, I did a talk called The Dangers of Shared Preferences. And so if you want some details on specifically issues with shared preferences, and I go through some of the source code in AOSP, you can go back and look at those slides or that talk. And unsurprisingly, about a year later, shared preferences, it's still there, it's still in the framework, and it still kind of works. Most people don't think there's a problem with it, but when you are deployed on tons of devices across the entire world, you start running into these edge cases where the storage fails or the disk is full, and with shared preferences, you just kind of get a silent failure and you don't know about it. And it works for things that are preferences, or maybe things that are not critical to your app, but if something is critical to use your app and it fails to save, like say your auth token, it's going to be an unpleasant user experience next time they open the app and something that's supposed to be on the disk is missing. So apps written at a lot of the large companies are deployed at what we always say is scale. And yesterday there was a panel discussion, if you saw it, that my coworker Ty led about apps at scale, and they talked through a lot of the problems that you face when you are dealing with hundreds of developers on one app or deploying an app to billions of users in the case of Uber, Facebook, and Google. And we want to maintain our user experience at scale. We want to make sure that for all billion users, they have a good experience. And when you're working on an app at scale, you start having to worry about the edge cases and the weird things that you say will never happen, because they start happening when you have billions of phones, and a lot of them are low end or maybe not fully CTS certified Android devices, or otherwise are not quite everybody on a Pixel 3 XL from last week. So specifically, I want to talk about storage at scale and the concerns we have to deal with when we are storing data on disk. And then I have a solution to help you with this. It's good for at scale, but it's also good if you just want to do things in a better way than shared preferences. So what is storage at scale when I talk about this? And I'm defining this as performing I/O operations on millions of devices, millions of times a day, globally. And if you say you want a success rate of 99.9%, that is suddenly in the thousands of failures. And those users may not be able to use your app. Or, for example, for Uber, we want people to be able to rely on the app to get somewhere. And if you open the app and suddenly you're logged out, or something's missing on disk, and you have to log in while you're trying to get somewhere on time, it's not a good experience. Additionally, at scale, binaries that you ship via the Play Store will live for years in cases without getting updated, because if you are shipped on a new device, so for example at Google, a lot of the Google apps are built into the device, and if that device is being deployed somewhere where network connectivity is either expensive or slow, so our best example tends to be India, where there's a lot of these low-end devices on bad networks that kind of see very spotty connectivity and often never see Wi-Fi. And those people are not going to update your app because they don't want to pay a quarter or 50 cents for the data to update your app. And so whatever you do ship, you can't necessarily just easily hotfix. So the other thing that I care about a lot is storage reliability. And why is storage reliability important? Well, it really comes down to the user experience, but also it can lose you money if you have a critical flow that needs storage and the storage fails. So here I have two examples of how to handle a storage error. On the left is if you were to use something that doesn't have error handling, that's a crash screen from I used an ancient device here. On a modern device, your app would just go away now, and you won't see the little crash dialog if you are an end user. On the right, however, I have handling a storage error and telling them in my very bad UI, because I'm a developer that doesn't do UI very often, a little note that says, hey, your device is full. And if you know what the error is, you can actually help the user fix it. So if their disk is full, you can say, hey, your disk is full. How about you go over to this other Files app and clean some stuff up so that we can log you in? Either way, crashing is unpleasant, but silently failing is also very unpleasant. Applications need to know when I/O fails, and preferably in a timely manner so that you can update the UI and not just hang on a spinner or something. A reliable framework for storage will give you either a success or a failure 100% of the time so that you can rely on that and move the user experience forward in the right direction depending on whether it succeeded or failed. Async callbacks improve the user experience. Having an async callback means you can show a spinner or a dialog for a critical operation and then move them forward at the right time. If you're using a synchronous operation and it blocks or takes a little while, you might actually get an application not responding. And if you have an error that the user can do something about, it's nice if you can tell them to fix it. SharedPreferences.apply, which is SharedPreferences async method, has no callback, and if it fails, you as the developer actually have no way of knowing that the apply operation failed. So here's an example code for storing something via shared preferences. And let's say this is your auth token, which you must have to launch the app in future instances without having to show the login screen again. Now, this code has two issues that they're not quite bugs, but they're usability issues that you could run into. And they're both here. So .apply, as I said a second ago, if that fails, you don't know. There is no callback here. This API has no way for you to know that it failed. Shared preferences commit does return a Boolean that is either false or true and will tell you whether the operation failed or not, but then you're blocking the UI thread. So Google recommends you use apply, and then you no longer know whether you had a failure or not. The second issue that you can run into here is kind of weird, and I found by accident when digging through source code, is that if I'm finishing my activity, it actually blocks finishing the onDestroy call on that shared preferences right finishing or failing. So in the framework code, onDestroy actually gets blocked on shared preferences flushing out. So if you're on a device where the storage or the SD card is not fast, you can actually cause an ANR on your onDestroy, which is a really weird bug that you'll never figure out why it happened. So another important thing is to be able to block progress in the app if storage fails when appropriate. So if you have some sort of illegal or privacy accepting a EULA type of thing, and you haven't necessarily saved that acceptance to disk or to your server, and your lawyers have told you that if you can't do that, the user should not use the app, it's very nice to know when it failed so that you don't end up with a problem later. So storage performance, which is the other side of this, and why is performance of storage important, is really just drop frames are annoying. There's a reason it's called jank, and no one says, oh, as a compliment, you know, that app is janky. That's not a good thing. And storage can cause frame drops. People, in the early days of Android, network calls on the main thread were a common cause of jank, other things along those lines that were really egregious. They've made the framework a little less forgiving on that and will tell the developer, hey, you just access the network on the UI thread and we'll crash you. But storage, you can still do that on the main thread, and maybe if you're on a brand new Pixel, once again, you won't have an issue, you won't notice. But if you are using a low-end device, such as when I was traveling in Paris and my Pixel died, and I needed to get a phone to use Maps and get around, I bought a 50 € really bad phone. It was a bad phone. Like switching apps was slow. It would just like opening settings took 5 seconds, and apps were really, really hard to use because you just drop frames all over. If you're trying to scroll on Google Maps, for example, you would just get jitter, and it's really unpleasant. And this is a phone that people buy and use day to day somehow, and I feel bad for them. And I want my app to work as well as I can on that bad device. So here's a example. And so if you notice there's a little bit of jank when you hit save. Right there, where it kind of locks up. And this I did simulate by basically putting a thread.sleep in the I/O operation of only, I think, 500 milliseconds, which on a low-end device is a pretty reasonable delay to have. And that's unpleasant, and really 500 milliseconds is not the worst case. It could be way worse. Then here, I have it using my new library without the thread.sleep in there. And it's hard to show in the video, but if there's with the thread.sleep, it's still smooth. Or sorry, with the slow I/O, it's still smooth. The UI doesn't lock up while it writes to disk. At the end of the day, it's really easy to drop frames because most devices these days are running at 60 frames a second, meaning you have 16 milliseconds to draw each frame. And especially on something like a tablet or something with a big screen, that's a lot of data you have to push anyways during 16 milliseconds on the UI thread. And if you start doing something else on the UI thread also, you are going to drop frames. And the P95, 95th percentile storage latency on a modern device is already going to be around 20 milliseconds. So even on a modern Pixel, you're going to get occasionally, depending on where you are on the disk, you might get a 20 to 30 millisecond read or write. And that there is 2 frames that you just dropped. Additionally, with performance, different types of data have different performance needs. If it is in the critical path to start using the app, it's probably you want it to be very performant. You want to block that you're going to be blocking the user on completing that operation. If it's something like a cache, though, maybe you just want to fire and forget. And I like to joke that SharedPreferences is a cache because it doesn't always save. And so if you want to cache, you could use SharedPreferences. But also, you can do some optimizations around caches. If the read is latent and you maybe know how long it would take to regenerate that data, you could decide at a certain point to time it out and just regenerate the data or go to the network if something has gone wrong. If a cache write fails, that's probably okay. You can probably keep moving along with your life and just log it so that you know that it's happening, but like the user should not notice if a cache is empty, for example. It might be a little slower, but they aren't going to not be able to use the app. And as I said, critical disk operations will probably block the user in some way from using the app as far as a spinner, and you want that to be performant. You don't want to have the user sit there and stare at a spinner the first time they use your app trying to log in. Something else I care about in storage is API ergonomics. And so what do I mean by API ergonomics? Well, a new developer onboarding to the app or a brand new developer who has not done Android before needs to be able to use the API in some way. They may not need to be able to use all the advanced features or know the intimate details of how it is implemented, but they should hopefully for storage be able to save something to disk. Additionally, though, an advanced user needs to be able to tune the performance. If I am the performance team, I want to be able to go in and tune my threads, figure out why or when things are slow, and otherwise get in the nitty-gritty of it. But hopefully that is not bleeding through in the main API, and you don't have to encounter that part day to day. Another thing that makes APIs nice is if we can use a common async abstraction. So I think RxJava is probably what you all are most familiar with. If you're using Google Play services, they have their own task wrapper, which is backed by listenable feature. So the 3 main ones I run into are tasks, listenable feature, and RxJava. Another one is just a plain old callback, like an interface with a success and a failure. That is valid. And then in Kotlin, coroutines are a possible option here. And doing the right thing and using this API correctly needs to be the easy thing to do. It shouldn't be easy to make a mistake, basically. Like SharedPreferences.commit is easy to call and not check the return value and just lose your data. Another thing that I wanted to do when designing this new library is to have similar behavior for both primitives and objects, so that if you switch from needing just an int to wanting a complex object, the API more or less works the same way. And also future-proof serialization. Your app is a living thing. It is updated, it is changed, you refactor, and whatever goes on disk needs to be readable by future versions of the app if you so desire. Another thing that's important is that the API needs to be easy to use correctly again, but if you can block your UI thread by using the API, maybe the API is slightly at fault there. So once again, SharedPreferences.commit blocks the calling thread. What if we just have an API that has no blocking operations? So at the end of the day, twice now at both Uber and Google, I wanted a key value store that ensured all these things, that it was performant, that it was reliable, and that the API was pleasant to use. So I ended up building it twice, and the second time I built it, I wanted to make sure we could open source it. So the new library is called SimpleStore, and it has been available for about 2 to 3 weeks on Uber's GitHub. We soft launched it and polished it up a little bit, but yeah, SimpleStore is a new library, and there's a URL if you want to it, and then I'm going to talk through some of the API design and how to use this library. So here is Kotlin code for writing a key to disk. And I'll walk through this, and yeah, it's readable on the screen. Good. So this is initialization. And I'll go into some more detail on what the namespace is there on the right later. But you have to initialize a store before you use it. This is very similar to creating a shared preferences instance. Here, though, we allocate some stuff in the background that ensures consistency across instances and that you can't corrupt your disk and that you have sane ordering of your operations. So you open your store, and then here in Kotlin, I'm using use, which in Java, you can use try with resources. The store just implements closable. And when you're done with the store, you have to close it so that we can release memory and clean up after you. The base API for SimpleStore does use listenable feature. There is, though built in or it comes on Maven, there is a optional RX extension that just swaps this out for RX Java. And I used features because it is actually shipped in Google Play Services already. So your binary size impact is negligible, and it's a very core Java library. And I didn't want to bring in any external dependencies that I didn't need. And the feature has a on success and on failure callback, very similar to RX. It's just instead of having 2 separate parameters, it's an interface you implement. The success will always give you an object if it is called. It is non-null. And then the failure will get called if something went wrong, and you'll get your throwable, and you can handle your failure case. This is the core of it, which returns that feature, and it's just your object, your store, put string, or put whatever value it is you need to put in. Then, with features, you actually have to always specify the thread you want the operation to go on. So this is something I do like about features over RxJava, is that it forces you to specify this because there's a parameter for it. And here I'm saying that when this feature returns, I want it to run on the UI thread because I'm going to update the UI. Underneath, inside of SimpleStore, I take care of all the threading and making sure that operations run on IO threads and there's a thread pool. You don't have to worry about any of that. All you have to do is say where you want the completion operation to come in on. So let me talk about namespaces, and that is a parameter you have to pass in when opening a store. And in SimpleStore, a namespace is the base unit that can be opened and closed. So on disk, it's basically a folder. You can think of it as a folder, and you open a folder, you can rummage around in the folder, write, read, and then when you're done, you have to close the folder. Only one instance can have an open folder at a time. So if you need to go to a whole nother set of code and use the same folder, you should close the folder first so that the other user can go into there. You're only allowed to have one reference to a specific namespace at any time. You'll get an immediate runtime error if you try and open the same namespace twice. This is to guarantee ordering within that namespace. So once your namespace is open, all reads and writes will occur in the order that you enqueue them. Across namespaces, there is no guarantees. So if you have a bunch of folders open, you can go crazy and write stuff and it will be in parallel. But when inside of a namespace, you are guaranteeing yourself a certain amount of consistency. This is that you don't have to think about threading. You don't have to deal with locks. You don't have to synchronize anything. You can just open the store and can use it from any thread you want as long as it is open. Here I have a code example of using RxJava to wrap the future. So RxJava actually has built in to single and completable and everything a dot from future. So if you're using RxJava, this is how you'd use the API. And it's very similar. It's just a little more terse, as the subscribe method takes in 2 parameters. So if you're in Kotlin, you can use all the Kotlin goodness for that. And fetching a key in RxJava, very similar idea. It's just get instead of put. So what were the design principles of this library? As I did in the intro section, we want it to be performant and reliable and easy to use. But specifically, there were some principles that I started out with when building the library to try and make it fulfill those needs. One of which is, of course, it's fundamentally async. I/O, and we had lots of discussion about this, I/O, in my opinion, and I think I would love to talk about this with people and hear your opinions, but that I/O should always be async, that synchronous I/O doesn't make sense because of the way it is implemented on a machine, that you are waiting for an interrupt to come back, and the hard drive is async and has its own processor and all that, and that having synchronous I/O is just a bad idea because you will end up blocking randomly. So I made the whole library async all the way down. Another design principle, especially with Kotlin in mind, is that you never emit null when you do a get. So if you get a key that doesn't exist on disk, you won't get null, you'll get the default of the primitive. So if you do a read from a key from an integer that doesn't exist, you'll get 0 out. If you do a read from a boolean, you'll get false, etc. This makes it so that you are null safe the whole way. You will not get a null pointer exception from this library. If you care about presence, so if you do care about the state of presence, you should just store a second key on disk of a boolean or such to explicitly track that. Another core thing that I wanted to improve over SharedPreferences is that it serializes as a byte array underneath. There's no XML parsing. There's no strings that are used to do keys on disk. It's purely bytes on disk. This means that if you are using some larger objects, which I'll talk about later, that your performance stays pretty good. And you can store whatever you want, of course, in a byte array, I hope. Anything on a computer can be stored in a byte array, as far as I know. Another design principle was that when you are done with your store, that you can release all resources. So that is the close. You can explicitly close the store when you're done, and the in-memory cache can go away, and nothing is left behind in your process. And then I wanted this to be configurable so that if you are saving cache data, you can actually use the cache partition in Android instead of sticking it in your internal app data, which is something where SharedPreferences fails you, is you cannot use SharedPreferences for cache data on the cache partition. We're going to dive into these in a little more detail. So fundamentally async, as I said, I/O operations are interrupt driven. And the implementation is that there is a shared thread pool underneath of I/O threads, and all operations go across that thread pool. In each namespace, we use an ordered executor to ensure that as a user, you get first in, first out from your viewpoint, but across all the namespaces, it is using a thread pool. Kind of talked about earlier, why didn't I use RxJava? Well, I didn't want to take on another dependency. Listable feature is already used by actually internally at Google for everything, and Play Services also uses feature underneath. Also, because RxJava has .from feature right in it, It's a one-liner without taking on another dependency. I like that. Listable feature also uses standard Java executors underneath. Rx schedulers have some nuance that can lead to issues with highly parallel I/O. And there is a talk from last year's droidCon SF by my coworkers Utkarsh and Johan about, what was the title? It was Rx schedulers and threads. You can go look it up. And they talk about some of the issues you can run into if you're running a ton of I/O operations on one Rx scheduler. So I decided to kind of go back to basics and just do executors because that's a Java primitive that's been around forever. And if someone were to port this library over to iOS via Kotlin multi-platform, I would expect them to do the same and to use the most native primitives they could. Never emitting null is nice for Kotlin users and just users in general, but also Rx streams are not supposed to have null. It's kind of awkward if you have a null in an Rx stream. And basically underneath, I use a zero-length byte array and I cast it to whatever object you're expecting, and that's what you get back out. So in the case of an integer, that's 0. In the case of a string, I give you an empty string. Serializes to byte arrays. So this is not only for performance, but it's also so that, once again, I don't have to take on any dependencies. The base class of SimpleStore actually only handles strings and byte arrays. I don't even do primitives in there. And this allows you to choose your own object serialization. In the main artifact, there is a class called primitive SimpleStore, which handles serialization for you if you're just storing basics. But this way, if you have your own existing serialization you use throughout your app, you can go ahead and just keep using that, and SimpleStore handles it. We are using a built-in primitive, and then we don't have to use JSON or XML, which has overhead of parsing, metadata on disk, stuff of that nature. You can also, with byte arrays, you can easily use things such as protocol buffers or flat buffers in the store. Another key thing that we have noticed in a lot of our apps at Uber is that people tend to hold on to their caches in memory way longer than they actually need them. And so with the closable, you can actually write static analysis to make sure that someone closes the closable. And when close is called, the in-memory cache goes away completely. This means that resources are freed. There is another optional mode that you can put it into where it goes into a LRU for your in-memory cache, so that if you're going to have a long-lived store, we can take care of LRUing that cache for you and keeping your memory load down. You could also conversely configure it and say, I want everything always in the memory cache as long as this thing is open if you have a singleton maybe that you're going to be accessing all the time in your app. So I also wanted to make sure that the configurations could be extended in the future for whatever new things come along in Android, which was handy for Q or 10 or whatever we're calling it today. That if you have scope storage, I haven't implemented it yet, but someone could implement scope storage for media, and you would just pass a parameter of the scope config in when you open the store, and we would handle that all for you. At the end of the day, the configuration is mainly about how to stick it on disk and where to stick it on disk, and it hides it from the user. Currently, it's similar to an enum. So here's using the cache config. You call create with your context, your namespace, and then your config. And right now it's enum-like, but in the future we could move this to a builder very easily so that we could have way more configuration available optionally if you need it. If you're just using SimpleStore for day-to-day stuff that is not performance critical as far as like being on startup, you can just go ahead and use no configuration and you're fine. It's good for data that's not on the hop path, and it can be LRU'd in memory. If you're performance critical, there's critical mode, which never purges that in-memory cache. So if you know you're going to be hitting this store over and over again for a lot of data, this is a good mode to go into. And yeah, as I said, Q, we need to implement that, but media scoping will work perfectly fine here. If you want to store more than just string and byte array, which I assume you probably do, primitive SimpleStore, it will implement that serialization for you using the standard Java representations. But if you have an arbitrary wire format that you like to use in your app, you can just go ahead and wrap it and delegate and save it as a byte array. So, you know, I was talking about all this. I talked about primitives, and byte arrays and strings, which are a common use case, but SimpleStore does more than primitives. And I have some companion artifacts around that help you with this. And this is something that we use at Uber is protocol buffers. And Uber is slowly moving to using protocol buffers in gRPC more and more. So we wanted to make sure that we were future compatible and users could store their models that are coming in off the network. So there is a companion artifact of SimpleStore-proto that enables storing proto-C based proto usage onto disk. If you use wire, I haven't written SimpleStore-wire, but someone could easily do that too. The nice thing with this is you can now atomically load a whole entire model from disk in a performant way. And so if you're using gRPC for your network calls, you can just cache your whole entire network call in SimpleStore using the request as a key and the response as a value. And you have a nice network cache ready to go. And my implementation uses Google's Lite Proto-C plugin, which is probably the best option these days for really performant programmable code. But if you're using a different Proto-C implementation, you can do that because once again, I just store byte arrays. So let me show you some code for using a proto here. And I have this demo.data proto definition, which has some fields in it that I'm going to use to populate a UI. So a good example here is maybe you have your user profile object. You can store that whole entire user profile to and from disk in one line, and then in your success callback, you get the entire object back out, and you can populate your UI. If that operation failed, or otherwise you had some weird I/O issue, you'll get a failure callback, and you can go ahead and handle that however you wish. In this case, I just basically show the error in a text view and then re-enable the button for saving. At the end of the day, I wanted to make sure that SimpleStore was modular and flexible because Android is always changing. We want to make sure that you can use whatever serialization format you like and that in the future I can change it if Android changes. So some possible enhancements, and pull requests are very welcome, is if you use coroutines or other Kotlin features, we can do a Kotlin wrapper. I'd love to have this interface be Kotlin native compatible so that if you are doing that path, we can use my current implementation on Android and an iOS engineer could make a similar implementation on iOS. I want to look more into automatic cache eviction and just general cache tweaks. And then pipelining within a namespace. So similar to CPU pipelining, it would be nice if we could see that if you are doing just a bunch of reads, those can all go in parallel. And as long as you haven't dirtied a key, we can parallelize on that key. And then another thing that I know we want at Uber is key auditing and cleanup, and using static analysis to figure out what keys and namespaces you've used in a binary. And then when you upgrade to a new release of the binary, being able to go and actually clean up after you on disk if you've removed things from the app. So contributions are absolutely welcome. It's a very new library. Try it out, file bugs, put up pull requests, write new fun things. It's open source. There's a link. Thank you.